Welcome to this webinar, Driving Growth and Efficiency in the Digital Era. I hope I am audible. Can you hear me properly?
Yes, sir, you are audible.
Okay. So, can you see the screen too? That's being shared. Is this?
Yes, sir, we can.
Yeah. Okay. Yeah. Thanks, Sanjay. Yeah. Thanks, Siddharth. Yeah. Hi. So, let's, Kavya, let us go on to the next slide, please. Yeah, so what we are trying to do here is, talk about AI and its relevance in today's world and what opportunities it actually gives. And, if you don't play this AI game, what would actually happen to us? Do we become a part of this large growth that is actually happening in India? Then Industry 4.0, okay, how so many free trade agreements India is signing with so many countries. So now what is that opportunity for us? What does it mean? If you want to grab that opportunity, how Industry 4.0 can actually help us. And then next tech, which is part of CASIA, how are we focused that we can enable MSMEs? Please remember this. We are not talking about big companies who have money, resources, talent to implement some of these particular things. We are talking about how Next Tech, which is a program for innovation from CASIA, how will this enable MSMEs to actually implement or adopt AI or Industry 4.0, etc. And then we'll open up the floor and have a Q&A. Yes, please. Next slide. So my name is Arun Prasad. I have over 35 years of industrial experience, out of which 25 years as an entrepreneur. I'm basically a mechanical engineer. So I am a certified Six Sigma black belt, but I have more than around 350 project experience of implementing Six Sigma all over the world. Then I do have international experience. I've worked in the US, I've worked in Germany and Japan. And I have around 25 high-tech product experience where I was either a part of the architect or I was the product owner. Okay, so under me we have established around 21 tech products. Yes, please. So yes, people, let's get on to this Industry 4.0 and why it is a compulsion. See, the word here is compulsion. Why has it become almost a must-have now? It is not a nice to have. So the world has to go towards this, and especially India has to actually do this. And the government of India also understood this, and they have a separate focus on Industry 4.0. They want more and more industries to actually adopt Industry 4.0 principles, basically. Okay, we'll try to find out what it means. Okay, Kavya. Okay, so if you look at this, a traditional business continues to do that. You have suppliers, you need logistics to bring in materials and take out materials, and you have some computers, some servers which are actually there. Some people might have an ERP, and then you have machines which actually does this, etc. Now, what does Industry 4.0 is what you see in that orange there is what is the change now. There is something called as digital production, okay, or digital factory or smart factories, okay. Now, this is what is the difference basically. In other words to say, you are bringing in the internet into your business process, okay. Now, this continues to do certain things, but the methodology of how you do is changing because behaviors are changing. All our earlier generation, one industrialization, two, three, all were focused on mass production. Now, suddenly, this has come down to customized production. That is where the world is heading towards. So everybody is grappling now because everybody was talking about productivity. Set the machine, keep doing this, keep producing hundreds, thousands, lakhs of products. That is how the whole focus was. Now they've suddenly inverted. Now, can you customize? Can you do this? Now, which works against the principles of mass production. Then what about productivity? How do we make money? How do we make profits? The way we are planning today, everything has to actually change. So we'll try to figure out what it means. Yes, please. Now, if you look at it, before industrialization, it was a village economy where majority of the times the village had unique skills. It was agrarian, majority of the times people, farmers. Okay, then there used to be a goldsmith family which used to provide gold, jewelry, etc. for the villagers. Blacksmith who used to ensure that the wheels, blah blah blah, etc. were all actually okay. Then there were somebody who used to stitch clothes. Now they were all happening within a village, and one thing dramatically changed: the steam engine. The moment the steam engine was invented, sometime in 1784, the power was more than you used to use horses or oxen and stuff like that to move material. Suddenly you had an engine, and this really collapsed the world, and this village economy concept went away. You had so much capacity that you used to produce so much that you could actually service 5 or 6 villages now. So this was the first time a concept of a factory came in. Instead of people doing things at home, they started building a specific place called as a factory. And this engine, steam, was giving them the capability to do this. Now, this is how this is called as the first generation of industrialization. Then, in somewhere in 1870, if you look at it, the power was identified. That is electricity, right? Now, suddenly, all these machines got replaced by electrical power, and even today we see there are very few gadgets which does not work without energy. We need electricity. That's how the whole world has actually redefined, and this did change, which increased capacities. So now larger factories came up, and then they started producing for the world. And between the second and the third, what actually happened? There were a couple of wars: World War One, World War Two, where there were a lot of requirement for armaments, for guns and some of those particular things. So the world scaled up to actually do that. And somewhere in the late 1960s, early 1970s was where the computer came in, basically. So suddenly there was an intervention, and that is what even today majority of the world is still working on the third generation where we are. We are using power, we are using computers, we are using some kind of robots are also there, conveyors are there. There are few things that are actually happening, but what is changing now is the fourth level. So if you look at productivity, which is there on the x-axis on the right hand side, the during the steam engine the productivity was very low. When electricity came in, it was a little bit better than what was for steam. And then the third industrial revolution actually ensured that the productivity went up. And in the fourth industrial revolution, just imagine, the productivity actually hits much more higher. And on the x-axis, you also saw the principles of scientific management. That is what became very active during the wars, basically. Post World War II, total quality management became the way. Then in 2000s, it was the lean manufacturing, Six Sigma. Some of those particular concepts what was driving this. Now we are moving beyond this now. Why? Because there will be high productivity. So this is what is the overview of Industry 4.0. Now organizations, even in the West, and of course this principle of in the fourth industrialization revolution was brought in by Germany, and then many German companies adopted this. Then the whole world initially was saying, oh, they're doing something, they have a lot of money, they have nothing to do, let us see how it works. And when it started becoming very successful, then the whole world realized, oh my God, we can't ignore this. If we ignore this, we'll be left behind. So every government stepped in, started giving incentives to their, industries to ask them to adopt this Industry 4.0. And India is also actually doing this. Okay. So the government of India is putting a lot of emphasis on Industry 4.0. Okay. Yeah. Let's get on to the next one. Yeah, so some of these particular things are there. First, what actually happened. Second, it's a little more in detail, basically. So the fourth generation is called a cyber physical system. So cyber is internet. Okay, internet with the physical systems put together is what is actually becoming. So technologies like IoT, Internet of Things, machine to machine, some of those particular technologies are redefining and helping adopt organizations to the fourth level of industrialization. Yes, please. Okay, again, product life cycle, if you really look at it. For example, some of the things that we actually see is, see, for any business, there are, if you don't have customers, you don't have a business, right? You need revenue. That means you are talking to a customer, right? Now, the situation with regarding to customer acquisition is not a joke. It is extreme, most critical for a company's success. The way you reach out to the customers, the way you are able to convince them that your products or service are very important, help them agree to the price that you are giving, get a contract, and then execute the contract. Except the auto industry, all other industries, the relationship with that particular customer ends when they deliver the product or the service. Auto industry is the only one which comes in and takes the benefit across the life cycle. The relationship starts because after that there is some service, the people have to come in, etc. So they harvest this because they've spent so much money in customer acquisition, and it is not, they keep that very long over years, that relationship. But just look at a TV manufacturer, look at a washing machine manufacturer, a refrigerator manufacturer, the company won't even know who their customers are. Sad. So now when you look at the product life cycle, what Industry 4.0 does now is trying to ensure that you can take this to the next level, keep that relationship, get more revenues out of this, of course, by providing value. Can you provide value beyond your contracts, basically? Can you have this relationship across the life cycle of the product? And that is what is typically called as, and majority of the MSMEs, we fail. We don't. We struggle and get the customer. We go into them for the next contract, but we don't give them anything beyond that. The engagement model itself is not there. And that is where Industry 4.0 comes in. Can we actually do this? Can we identify? Can we resell something? Can we buy back and give them something else? All of this, the model can change, basically, because the cost of customer acquisition, you get more benefit rather than just that particular transaction, basically. Okay, next one, please. Okay, now these are some of the technologies. When you talk about Industry 4.0, not necessarily all of them, even few of them, if you are able to adopt based on your needs, is the requirement for an Industry 4.0. If you look at it now, okay, let me start with cloud computing on the top. So definitely days are gone where you have a server inside, maintain that, blah, 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 etc. Cloud is actually available today. Put that in, and then you store your data, you process your data in the cloud. This is becoming a norm. Mobile technologies, yes, today you need to have some kind of an application which you can reach, the customer can actually use, etc. Okay. Machine to machine communication, where two machines talk to each other. Typically, wherein, so there are many networks which are actually available. I don't know, many of you today, in recent, people who have credit cards or debit card, there is something called as an NFC, near field connectivity. Today, you don't have to swipe your card. You just take it close to the POS, and then it recognizes and does this. So that is also a network. That's called as an NFC, right? Then you all know about RFID, okay, radio frequency identification device, for example. FASTag has actually enabled that. So you actually are actually using this. Now we know about Wi-Fi because majority of us are using this. Like this, there are multiple ways through which machines can talk to each other, basically. Of course, then 3D printing. Now you won't believe, guys. I don't know if some of you have bought a suitcase for travel in the last 3 to 6 months. Those traditional suitcases are not available today. So what is the new material? It is all carbon fiber. They're just around a kg. Because if you're doing international travel, they come back and say your bags cannot be more than 22 kgs. If your basic suitcase itself is 3.5 kgs, then you have only less kind of things to put in. Today it is just around a kg, but it is stronger than steel. So this revolution of adoption of alternate this thing, this was enabled through 3D printing. Same way, lot of small industries. You know how much you help your large industries in innovation? You don't even know. They're pushing on to you. You're just approaching this. And they are getting the benefits at your cost. And that is where, can you create a prototype much more faster? 3D printing. Today, just imagine if somebody is wanting, give me 5 pieces for evaluation, a sample. You go to the market, you don't get steel only for those 5 pieces. You'll have to buy in tons. And what do you do with that? That takes the cost much more, unnecessarily burdens the MSMEs. Can you actually put a 3D printer? You can print steel parts today. You can do carbon fiber. Of course, plastics. So now 3D printing is a big way going on. This actually brings in efficiency. It helps you innovate faster. Okay. Then advanced robotics. Now robots were already there. That is what is called as adaptive or smart. Just like driverless cars, we are talking about adaptive robots. It knows exactly. There are no rules. Nobody is controlling this. It should automatically be able to do. They have actually started having systems like that. Of course, big data. The moment you are doing sensors, that this, etc., a lot of data in real time. You can use analytics to actually identify this. This is becoming very important. Then, of course, IoT. For example, this is a wearable now. Today, when you see, I have, for example, let me show you this. This is a smart glass, okay, from Meta. I can talk to it. I can ask questions. It has meta intelligence actually embedded in this. It can do so many things. I can make a video call. Okay, as I am seeing, I can ask a question. I can ask for the weather in Bangalore. It knows exactly. So this is again wearable now. How does it work? It is working with my phone now because it's on a Bluetooth. Okay, so now more and more smart rings, for example, right? You have smart rings. Now they're talking about smart clothing. It will do real time, assessment of your this thing, sweat. And then it can come back and tell you what's wrong with you. Are you losing energy? Should you actually have something? Is your sugar levels going down? Do you need to actually put in maybe a toffee to increase this particular thing to get a bump of sugar so that you can get back to your optimum energy levels? All of those particular things are actually happening now, right? So the question is, now look at some of those earmuffs that are there. They're also turning it into earlier people who deaf people, they never used to have this hearing aid, right? Now they're also working as hearing aid. You can normally do this. Plus, if you are having some kind of this thing, it actually amplifies this and works as a hearing aid too. All of this happening because of Internet of Things, basically. Okay. Then, of course, RFID. We did talk about it. Then cognitive computing. That is where the smartness, the AI part of it is what is coming actually there. And of course, since you're exposing a lot of things onto the cloud, you need cyber security. So all of these particular things are a bouquet of technologies which are related to industry 4.0. Not necessarily that you'll have to implement all of this. Again, depending on the purpose and depending on what you're trying to do, you can pick one or more of those particular things which actually helps you move from your traditional industry 3.0 style of functioning to industry 4.0 style of functioning. Okay, yeah, let's. Okay, some of the benefits are, I did talk about efficiency, agility. You won't believe, a close friend of mine is a plant manager for an automobile parts manufacturing company. It's a large, they have around 25, 26 plants basically all over the country, some of them abroad also. Now he was saying the whole management style has changed. Earlier, one product, you set it up, not only one shift, second shift, third shift, next day, three shifts, four shifts, and then you take in a new product because volumes were defined. You used to know this. Companies used to sign up contracts for 3 years, annual plan, blah, blah, blah. That was the method. Today, he says he has to change the product 3 to 4 times in one 8-hour shift. Now, and every changeover takes around 30 minutes, 40 minutes. So if you're doing 4 or 5 times, you know how much amount of loss of production basically. Now, suddenly he says, oh my God, my systems are not agile enough at all. They are not alive, they're all fixed. And when I try to do this so much, so that's what agility is one thing which will improve with Industry 4.0. Innovation, it helps in innovating, then helps in improving customer satisfaction. Yeah. Yeah, costs. Another thing, the the transaction cost needs to actually reduce. Okay, and then big thing about this is agility. As I was telling you today, traditional automobile companies, one line, two lines, three lines, four lines, one line will always have 120%, 130% of the load fully busy. There are other lines which are not busy at all. Now, suddenly you see, if you take the overall average, one line you'll have to run three shifts, one line you'll have to run only one shift. So much amount of complications. It has become really, really difficult. And why? Because it is very rigid. There is no agility. Can we do this? And that is where I gave you that example of the Volkswagen plant in Germany, where they can switch over in no time. Parallelly, so many products are actually doing, and you know what is actually doing the line. There is nothing called as a production line. They are all in different places. This keeps going. The AGV is the one which takes the material into this imaginary line and they get produced at the same time. 4 or 5 different models are being done at the same time. It's not dedicated to one line. So much amount of flexibility and agility they are able to. So they are able to reduce numbers. Even if you look at painting now, all of these are dip painting, right? Automobiles especially. Now, once you decide to have red color paint, there are so much of formalities before the process, cleaning, blah, 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 etc. Then the paint is fixed, and then you have this, and then you want to change over, you have to drain the paint, clean all over and put the new paint. This is a huge bottleneck. Now suddenly you see people are now coming back and saying, I want this color and that color put together. Today, these systems cannot handle that kind of flexibility at all. Now, Industry 4.0, you need to have flexible systems basically because the customer is the king and they are changing. Nobody likes the same kind of product, two people having the same thing. Now, why? Because the profile or the psychology of the customers themselves are changing, and this requires agility now, right? So this is what will actually happen after a Industry 4.0 implementation. Yeah, please go ahead. Okay, so interoperability, this is one very important thing. Today, you take this system and another system, they should talk to each other, or it will become like this. Just imagine one of the things, suppose you're on a trip to the US and you brought some electronics from there. Let us say you bought a phone, okay? And then you came to India, you have the charger. Can you actually use the same plug that we have at home? right? It is not there. You need to add something if you have to ensure that the charger works in India, right? So it is not interoperable. The plug of the US cannot go into the socket of the Indian thing because our way is different from what their way is. So they don't talk to each other. It's just a small example of interoperability problems. We work at 50 hertz, they work at 60 hertz. We work at 220 volts, they work at 110 volts. We drive on the left side of the road, they drive on the right side of the road. All these are not interoperable at all. So systems have to talk to each other, and that is one very, very important fundamentals for this thing. Make it more interoperable. You want to change a sensor and put some other sensor, it should be very easy and adaptable to do that rather than throwing the whole system and bringing in a new system. Okay, and the other one is real time. You should be mentally prepared that all this should work in real time. It can't work in batches. There is nothing called as batching here. It is everything is almost on real time. Okay, decentralization again, nothing gets centralized. Decisions have to be taken at the machine level. Data has to talk to each other. There should be a processor here. Local decisions can be taken. And then there is something at the server level where some particular thing. So they're totally decentralized basically. And the way our management system now, who should approve, who should do, all of this will actually change because of this decentralization. Okay. Yeah. Okay, virtualization now. Another thing, I don't know how many of you know about this. If an organization decides, a typical, again, going back to the auto industry, they have an idea of a new model, okay, and they launch the new model. The time span between thought to the hitting the road or the commercialization generally is around 7 years. 7 years, guys. The same thing in a pharmaceutical industry. They want to come out with something, a molecule, by the time they can actually commercialize, 7 to 10 years. Now there are two examples of what Industry 4.0 approach and AI approach changed in the world. One is recently BMW launched their electrical SUV, ESUV. 1 year idea to launch, 1 year. Where is 7 years and where is 1 year? Same way, vaccines. Vaccines take 7 to 10 years to actually, it has to do field trials, that there's so many things before it can be commercialized. The world, people were dying every other minute and second, people were dying because of COVID. So that the world needed to come back and then create a vaccine which can protect the world people. Now they did it in around a year's time, which is wonders basically. Because previously, if you look at it, you all know about what is called as HIV, right? HIV virus. The world failed miserably. Even today, you don't have a vaccine for HIV, even after 25, 30 years, because of so much regulation, so many things, the approach to life, blah, 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 etc. Whereas humanity, the best of humanity came out when we did this vaccine within 1 year, millions of lives were saved. No, these are some of those particular things for which one of the biggest thing is what is called as virtualization. They do what is called as simulators. For example, a pilot, either a commercial pilot or the Air Force pilots, they don't touch the aircraft at all. For many times, they all work on simulators. They have to get competent. That's a virtual system. Only when they come in. Now slowly you see Maruti has done this. Even for car driving, you start with a simulator, and once you are comfortable, you come to the road, you're almost as good as a nice driver. Otherwise, the frustration here is first day itself, they'll get onto the street, the most crowded time, and then they pulled up the traffic basically. It was a frustration. Whereas now, if you see simulation, there is a concept called as digital twin. which is nothing but a mimic of digital. You can do a lot of things before you actually do it in production, basically. So a lot of virtualization is one of those particular things. Okay, then modular to bring in flexibility, blah blah blah, etc. Classic example is Facebook. You look at Facebook today, you open up, you have a lot of features, right? All of those are one app, one app actually. They have a beautiful integration. They're all modular in nature. They can actually add in. Suddenly you use this, and tomorrow morning you're looking at the Facebook. There's a new change. How did it happen? They made it modular in such a way that, so these are some of those things that managements have to adopt to make this basic industry 4.0 successful. Then service oriented. Now just product alone will not work. Selling a product, can we sell this product as and also part of a service, for example? Okay, so a lot of service orientation is actually required. Okay, sorry guys, I think we have 15 minutes more. I hope, is it okay that we continue, or I'll try to quicken this. Is this okay?
Continue, sir.
Oh, thank you, thank you, thank you. So again, so here if you look at it, the architecture is like this. There is a digital enterprise and there is a real enterprise. The real enterprise are the physical assets and stuff like that. On the digital side, there is, that is what jumps in, whether it is communication, data, functional processes, business strategy, all of these are in the digital side. And this is how, using all these technologies, you're trying to control some of those particulars. Yeah, let us get on to the next. Yeah, this is what real world versus the digital world, how you can design this in the digital world, blah blah blah, etc., and then it can hit the real world basically. Okay, across the supply chain, engaging suppliers, engaging this, because if you do this as an ecosystem, it is much impactful, especially with regarding to the industry 4.0 adoption. Yeah, and across many tiers of vehicles. Okay, so now if you look at it, yeah, go ahead. Yeah. So now if you look at what is it that is required for an organization if they want to adapt, what kind of skills are actually required? People who have critical thinking, people who are conscious about real-time decision making, service orientation, scalability, complex problem solving, of course, hence artificial intelligence, advanced analytics, cognitive intelligence, innovation, and people management. For example, let me give you one example of how, what is the difference. For example, suppose, you, any retail store, okay, today you enter this, they have lanes and lanes of materials, right? Materials, health products versus beauty products versus personal hygiene products, like this. There are so many things that are there. Now, from a human intelligence perspective, if there is there an affinity or a relationship between two products, toothpaste and toothbrush, you don't need smart intelligence to say that they are very closely related, correct? No, same way with regarding to, let us say, maybe soap, okay, and let us say shampoo, okay, they have close affinity. A shirt and a pant has got close affinity, like this, right? Now these are all much easier with experience. You don't need people, you don't need analytics. Human intelligence is good enough, we can process this. But let me give you one situation which will shock the hell out of you, because it is beyond human understanding. They found out that first time fathers, okay, first time somebody has become a father, okay, so this can be anywhere between 23 years to 32 years, okay, this is the range of the age, okay. These people, when they go to a store to buy baby napkins, okay, napkins for the baby, definitely, the first time father, so it's a young kid, so he needs this. When they go and buy baby napkins, they also buy beer. Where is the correlation between baby napkin and beer? This beyond human understanding. Why is there a correlation? You know what? deep analytics actually found this out, saying that there is a correlation, boss. So if you go to any of those first world countries, when you have a baby napkin, just look around, you will have beer close by. No, there is no affinity between beer and this. Toothpaste, toothbrush, you can understand. Soap and a shampoo, you can understand. Shirt and a pant, you can understand. But this, so there are so many relationships which you need to actually do this. And that is where artificial intelligence and cognitive intelligence, as they say, needs to actually come in. And of course, innovation, exciting people, bringing out the best. These are some of those particular things that are required for organizations to adopt 4.0, and this transformation needs to actually happen. Okay, yeah.